Alrighty then. Okay, you people, this is geometry. This is my AZMerit review, and we're going to go through and actually do a lot of the questions, and you guys are going to help me and interact with me about what you would do when you see this question right here. Okay, it says, for this, use the graph. Which segment is congruent to, and in this case right here, I'm going to be working with EF. So it's not on my thing, but it's going to be EF. There we go. EF. If you saw this on the test or AZMerit, what would you do to try and solve for this? What did we do when we actually had this before, when we were talking about congruent segments? What did we do in class? No, it is going to be rigid, but what? I heard something. Patty paper, thank you. Patty paper. You guys remember the patty paper? We would actually trace that out and look to see which ones are congruent all the time. Yes, which shapes are congruent by doing that. Now, that's one way of doing it. So we could say, all right, one of these other ones, so how many units, how long is this one? 5 units, right? That's 5 units there. So I got to do some math to try and figure out the others now. So all these are going to be right triangles. And all these other ones right here are all the hypotenuse of these right triangles. So, like I said, these are hypotenuse of the right triangle. So we're trying to figure out the values of each one. Okay? So, for this right here, so let's start with GH. So, Pythagorean Theorem for each one, so it'd be, let me see, this value, which is 3, right? Yeah. So, for GH, it's going to be 3 squared plus 1, 2, 3, 4, 5 squared equals C squared, right? Yes? Yeah, that's going to be my Pythagorean Theorem for that one. So I get 9 plus 25 is 34? Okay. 34 equals C squared. How do I undo a square?
Square root.
Very good. So it's going to be a square root of 34. So C equals square root of 34. Okay, so let's see. Let me see. So GH is, now calculate that for me, please. 5.8. So, like I said, I need everyone paying attention, following along here. All right. Okay, so I'm going to do this again. So that one's GH. So the next one I'm going to do is, all right, there we go. So we did GH. So let's do CD. So now for CD, that's going to be equal 2 squared plus 1, 2, 3, 4 squared. That's equal to my C squared. So right here we're going to have 4 plus 16, which is
18. 20.
20. So undo the square root, C square root of 20, right? 4.5. So CD 4.5. All right. Okay, I'm going to clear that one up. All right, next one. Last one, AB. So AB is 1, 2, 3, 3 plus 1, 2, 3, 4 equals C squared, right? So Pythagorean Theorem here, I get 9 and 16, right? 25. So 25 equals C squared. And then C is equal to square root of 25, which is 5. So this one right here is going to be 5. So it's asking which ones are congruent? AB is congruent to? So AB is congruent to EF, right? Line segment. Okay? So a lot of stuff that we have done before. Just got to refresh it. All right, midpoint. Now, midpoint, this is something that we did not specifically cover in here using regular means, but this is stuff that was math from years ago. Okay? Midpoint formula. So this one right here is going to be the midpoint of CD. So this one's CD. So midpoint of CD. So I'm going to show you guys. Now, there's a way of doing it on a graph, and then there's a way of doing it using a formula. So, which one do you think is easier? Graph is actually going to be easier, right? Okay, so let's take a look. So halfway in between. So if I'm looking on a graph right here, so I'm going to change colors so we know which one we're working with right now. All right, so we're dealing with this one right here, right? All right, so what is half of the y value?
1, 2.
It's going to be 1, right? Because this is 2, so that means I have to go down 1. All right, what is half of the x value?
2.
It's going to be 2, right? So halfway in between. So now, where is that going to put my point? Right here, right? That would be the midpoint M. That would be, let's see, that's going to be at 1, 2, 3, and 4.
What if the y was 3 and the x was 5?
You get a half. You get a half, right? Okay, halfway in between. All right, so now I'm going to show you guys the formula to go along with this. So the formula is going to be x1 plus x2 over 2, comma, y1 plus y2 over 2. Because this is going to be the midpoint in between two endpoints. Okay, it's a midpoint in between C and D in this case right here. So midpoint in between C and D. So the x value for C is going to be 1, right? 1 plus the x value of D is 5. Okay, over 2, comma, y value of 1 of C is going to be 5, plus the y value of the second one is 3 over 2. So this is my midpoint. So 1 plus 5 is 6, divided by 2 is, and 5 plus 3 is 8, divided by 2,
4.
and that's my midpoint. So it's a midpoint formula, but you know it's just halfway in between. So if you're looking at the x, how far they're apart, you know, you could use that, and using graphs is very, very helpful. All right, use the following information for this, and it says that JKL, we had a problem like this on the AZMerit review, the practice test. Okay, you guys are actually seeing some of these that have been doing the Khan Academy. So for this, we're going to have, let me see, KJL. KJL is 32 degrees. This piece right here is going to be this. So this is 5x plus 3. There we go. So first thing I'm going to do is solve for x. I know in this one right here, to solve for x, I need to have two values that I know. I know what KJL is. I do know what that is. What is that? 32, right? The angle is 32, right? Okay, so we're going to get 32. So I know that 32 has to be equal to this also. So 3x plus 11. Because that, what's inside there, has to equal the total amount. So we get, go ahead, subtract 11. 21 equals 3x divided by 3.
7.
x is 7. So right here, this is going to be 7. You got both earbuds in, not even trying. Here. Pretend like you were home. Okay, this next one, the symbol came out wrong. It's supposed to be, what is the measure of angle KJM? K to J to M. So, let's take a look. Do I know what this piece here is?
Yes.
This is 32, right? Do I know what x is?
Yes.
I know x is 7, right? So what am I going to do with this x?
Plug it in.
Plug it in right there, right? So it's going to be 5 times 7 is?
35.
Plus 3?
38.
38 degrees. Not too bad, right?
Wait,
So, if you guys have your notes out,
Mr. Boston, I don't understand because it goes from all the way up right there, so wouldn't it be 70 degrees because you're adding it? Because the angle is...
yeah, you're right.
You gotta write that down.
You have the notes for this, right? So if you guys are following along with this, or because some people are just trying not to go to sleep, or actually just trying to go to sleep. So, I had one person notice my issue.
It's me.
I had one person notice my issue.
What's the issue?
What am I looking for here? I outlined it in red. KJM. I'm looking for KJM, right? But I asked, what did I write down here? 38. Is that correct? No. What do I have to do? I have to add them together. Thank you. Thank you. It's going to be this one plus this one, right? So together I get 70 degrees. Good? Ah, there we go. Okay, line segment PQ has endpoints rotated 90 degrees clockwise around the origin. 90 degrees clockwise. So, let's see. Okay, we had rules. We made rules in our notes for this. So if I rotated 90 degrees clockwise, I could either use the rules, or I could actually try and figure out what it's supposed to be. So it's supposed to be, P is at 4, 2. 1, 2, 3, 4, 1, 2. And, let me see, Q is at -2, 0. Right here. You guys will like this next step. Yes? We're rotating this whole thing 90 degrees clockwise, right? Ah. Nine degrees clockwise. When you guys do this, what are you going to have to actually rotate? You guys got patty paper to do this, right? So whenever you have something like this, you can just put it on the patty paper. Now, I rotated it. Where is Q prime now? So, okay, so but I need a value for there. Is where? 0 and 2. Where is P prime?
-4.
Nope, nope, nope. X value goes first.
+2, -4.
So it's +2 and -4. Okay. Okay, so now we did that, right? Okay, let's look at the second part of this question. So we could use the formula, or I could try and use the graph. You could use the formula or try and use the graph. Okay, let's see. Formula. So I'm going to have, let me see right here, is 0 plus 2 over 2 and 2 minus 4 over 2. It's actually plus -4, but I just changed that to -4. So it's going to be 2 over 2, which is 1, and -1, right? Now let's see. Watch this. Let's do the x and y again. Yes.
Aren't you subtracting them?
Yeah. No, I'm adding them. Okay.
Oh, you're adding
2. Yeah. 2 plus -4 is -2, right?
So the formula isn't subtracting.
It's always plus.
Adding. Okay.
It's always adding, but because there's a negative here, it's plus the negative number. All right. So now what about? Let's do it on the graph here. It goes over 2, right? So if it goes over 2, halfway is 1. If it goes up 1, 2, 3, 4, 5, 6, halfway is 3. So that's going to put me right here, which is 1, -1. Please follow along. It's not nap time. This next one says, state the converse of the statement. Now, this is one of the topics that we have not got to at all. We have not talked about converse or inverse or contrapositives or even just true statements. We haven't talked about any of those. All right, now, okay, I'm going to go over it. So converse is where I take my second part and I change it with my first part. Okay, here's a good example. I'm saying that all thumbs are fingers. Is that a true statement? All thumbs are fingers. Your thumb's not a finger? It's a phalange. It actually is medically. So, but now, here's the converse of that statement. Are all fingers thumbs?
No.
All fingers are not thumbs. That's the converse of the statement. So now let's look at this. It's a finger. And not all fingers are thumbs. Okay. So for this one, if two angles are vertical, then they are congruent. Okay, so let's do that. Let's flip it around. So if they are congruent, then two angles that true?
Wait.
So just because I say they're congruent doesn't mean that they're vertical?
No.
Could there be congruent by any other means? Okay, yes, it could be corresponding. It could be alternate interior, right? Alternate exterior. Okay, so this one is going to be false. This one is not going to be true.
How would we explain it?
Okay, it is explained because, like the statement I said, okay, it could be alternate interior. Just because it's congruent doesn't mean it has to be vertical. Okay, because it could be congruent and be alternate interior or alternate exterior, something like that. Okay, that would be my reason. Okay, so that one's for that reason. Now, here's another example of a converse statement. Okay, and I want you to think about this. So before you actually go shout it out, I want you guys to think about it. Think about it carefully. So you're going to do the converse of this statement and tell me if it's true. Okay, but think about it. Don't yell stuff out. Okay, so I'm going to say all lions are mammals. This is science, okay? Now you have to think about it. Now you have first think about the converse of the statement. Now that you thought about the converse of the statement, is the statement going to be true?
No.
All mammals are lions.
All mammals are lions is the converse.
That'd be false because there's multiple different kinds of mammals.
Yes, could be a bunch of different mammals. Just because it's a mammal doesn't mean it's a lion. Does that make sense now? Okay, good. Hopefully. Even those people like sleeping about it, they're thinking about lions and tigers and bears. Lions and tigers and bears. Oh my. Come on. At least sit up. Sit up. Come on. Pay attention. No, you won't. You'll go right to sleep. Why don't you just stand up? Stand up. That'd be even better. Yeah. Okay, you can stand up back there, okay? All right, so we're using this graph, right? Her, up in her. Yes. That thing just went. Oh, I thought you already did. I'm sorry. I thought you did when you got back. All right. Write the vector that maps RST onto R prime S prime T prime. Okay, I'm gonna do some neat stuff here. So I'm gonna trace it out. Okay, so now I got this. Now let's see what I got. Does it go directly onto there?
Yeah. I think you said that. It like slid.
Yes, so it goes directly onto there. Okay, so I know that they're going to be congruent, right?
Yes.
Now, let's do the notation for this one. So R, sorry. Okay, so now let's look at R. So R goes which way? To the left, right? So that's going to be X minus, how much does it go to the left? 1, 2, 3, 4, 5, 6. There we go. All right, now Y. Is it going up or down?
Down.
It's going down, isn't it? So it's Y minus. Let's see. 1, 2, 3, 4, 5, 6. All right. That is the coordinate notation. Yes. Yes. That's the coordinate notation. Now we're going to turn it into a vector. Remember, what does a vector look like? It's got little pointy ends, right? Okay, so it's now just going to be pointy ends like this. But now instead of actually saying X and Y, so now we're just going to say,
Negative X, negative X.
so this is going to be -6, and -6.
Say negative x. I'm sorry, I meant 6.
Okay, yeah, it's good. I know what you're talking about. So it's going to be -6 and -6. All right. Is that easy? Hopefully. Use this one right here. It says for figure 8 and 9, how many lines of symmetry does a figure have? Now, symmetrical. What does symmetrical mean? Yes, basically you can fold it in half and it'll look exactly the same. Right? Okay, so now this is a regular pentagon. So that means all sides are the same and all angles are the same. It's a regular pentagon. That's what that means. So let's go ahead and draw a line of symmetry here first. I'm going to start straight down the middle, right? So there is 1. Do I have another one? Do I have another one there? Yeah, basically I do, but my drawing's not very good. Okay, so I have another one, don't I? So I have another one right here. There's 2, 3, 4, 5. Yep. So we have 5 lines of symmetry. What's the angle of rotation less than 360 for the figure?
Yes.
Do you guys recall what I did this?
That's 180.
There was a special thing we had to do. And it starts with 360. Yeah, that's a whole rotation, right? Okay, so how many times can I rotate it and it'd be exactly the same? 360 over 5, right? Do you guys remember when we did that? It's 360 divided by n, and n was my number of symmetrical lines, right? Yes? Okay, so what do we get there? 36 divided by 5?
72.
72 degrees. Use the following information for 10 through 11. Okay, in the figure below, triangle ABC is congruent to triangle LNM. Okay, AB. What side is AB congruent to? NL. LN, right? LN. Why do we know that? AB is congruent to LN, right? Okay, so now I'm going to set this right here equal to LN, which is 24. Very good. So I'm going to do the math right here. So I'm going to say that 2x plus 6 equals 24. Got to do some algebra here, right? All right, so what do we get? So subtract 6, then divide by 2.
9.
We get x is 9. Okay, now let's do the same thing for the y value. All right, that's going to be LM over here. I'm going to change colors on this. LM is this one right here. And what does LM go with? LMAC, right? So I'm gonna have 9y minus 12 equals.
103. Because you add the 16 and 42 in the end. Right?
So see this little thing right here? What is that right thing? What's that little dot in the corner mean? That's a degree sign, right? So if it's degrees, what do we have to look at?
The ones inside.
On the inside, right? So let's see. I'm looking at inside now, right? All right. So that's gonna be. Let's.
102.
That goes with here. So what is M? M is congruent to C, and C is 60. There we go. So that's going to be equal to 60 there. Now I can do the math. Now I can do the math on that one. So add 12, so I get 9y is 72. Divide by 9. Y is 8. Yeah.
So N is congruent to C, but A is also congruent to L. So why did you choose?
No, it's this one. This is the angle that it is.
Okay.
This is where it goes. I could try to, make this a little bit bigger, but yeah, this is the angle where this one goes.
Okay.
So if it would have said like a little arrow pointing here, would that be better? Yeah, it's referring to this angle right here. So since we're referring to that angle, it has to go with that angle. Okay? Does that make more sense? Okay. Let's take a look at my next one. Use a graph. What transformation can you use to show that quadrilaterals D, E, F, G and D prime, E prime, F, G are congruent?
A 180 rotation.
Let's see. So I'm trying to put different color.
She write that. Yeah.
All right. Let's see if I can get it now. Ah, too big. No. Trying to be fancy. So get for being fancy. Ow. All right. It's not working. Can't get that fancy. Anyway, let's try and rotate it now. There's 180, right? And does that put it there?
No.
It doesn't put it on there, does it? Okay, so that one doesn't work. So let's try something else. So you said 180 degrees rotation. No, that did not work.
What about reflect?
Reflect. So reflection.
Like the thing you did Tuesday where like it flipped across
180
the Y and then you flipped it again across the X.
Okay, so you're saying we're flipping it?
Yeah.
There is a way of flipping it. I'm trying to remember how. There it goes. Okay, so now we are going to mirror x-axis. It's up too high. Anyway. Ah, dang it, it's not working. Ah, angry face. Anyway, this one, we have to try and put F onto F, right?
Yeah.
So if we put F onto F, there we go, F onto F. So this has to end up down here. D has to end up over here, right? So I know there has to be some type of flip, right? So if I flip this over, if I flip this over right here first, right here, let's flip it across the y-axis. There we go. Ow! Okay, so I know it's going to work because this thing does not like me today. There we go. All right, so now and I tried so hard. All right, so we flipped it across here. So that's going to put me over here. Does that put D in the right spot?
No.
D is right here. It goes from here to here. And now, what is it going to do now?
Just slide it.
Now it's going to be a slide, right? So it's going to be one to the left, right? So let's see. Ah! No! Alright, so this one's all foobar. Anyway, so we said that it's going to be going this way. So I flipped it over the x-axis, so it's a reflection. Across my y-axis, I said x. Now, we're going to move it down, so it's going to go left, left 1. So it's going to be x minus 1, and it's going to go down 6. 1, 2, 3, 4, 5, 6. Y minus 6. My board is not liking me today. I think I've tortured you guys enough. Did I torture enough yet? Okay, I did? So that's enough? Okay. So we're going to pick on number 13 tomorrow. Don't forget, like, share, and subscribe.